Have you ever wondered why some of the bags of your food storage are quite different? I have this one that's filled with egg yolks that's really tight and very compact. But then I have this one filled with cabbage that's thick and bulky, and they're absolutely different. This one almost looks like it has been vacuum packed, where this one has a lot of air in it. Have you ever wondered why is this? Well, we're going to delve into this, and it actually comes down to a little bit of science. And you know how I like science. I received some comments a while back about oxygen absorbers and how some of the individuals out there in YouTube land are not happy with the oxygen absorbers because they didn't suck in all the air inside the package to make it nice and tight. Well, oxygen absorbers can only suck in 21% of what's contained in the bag. They can't suck in everything, but they can only suck in the oxygen if the oxygen absorber is rated properly. So we're going to delve into this on how you can get your packages nice and tight like this one almost every time. And it has really nothing to do with the oxygen absorber. It actually has something to do with this old tin can. I have here a standard food storage bag. Now, it doesn't matter if this is mylar or polyester. It's a food storage bag, ones that we use all the time. Nothing unusual. But what would happen if we put something warm inside this bag? Or if we made the air inside this bag warm, and then we were to seal this bag and let the warm air inside the bag cool down? What would happen? Well, we're going to do one of my most favorite science experiments from my 7th grade physical science class. So what we have here is a basic 1-gallon metal can. What we're going to do, we're going to warm the air up inside this can. Now this is going to be a little bit hotter than what would ever be in a food storage bag, but we do need this air a little bit hotter to make the demonstration of what will happen when hot air cools down inside a container. So we're going to go ahead and turn this on, and we're going to heat the air up inside, and once the air is nice and warm, we're going to turn off the fire, and we're going to put the lid on, and we're going to see the magic happen. Okay, so I can feel the heat coming out of this, so we're going to go ahead and turn off the heat, and we're going to take the lid, and we're going to put that on nice and tight. When the lid was put on the can and the air cooled down, it created a lower pressure inside the can. So the higher pressure around the can wanted to just crush it. So you can kind of see what's happening to this can. It's virtually folding in on itself. So, if we can get a food storage bag and put something warm inside, for example, nice hot food right out of the freeze dryer, and put it inside the bag, that food is going to warm the air up inside the bag. And if the bag is sealed, that air inside the bag is going to cool down, and it's going to be a lower atmospheric pressure inside the bag. And the atmospheric pressure around the bag is going to basically want to squish or crush whatever is inside the bag, because nature wants to find a balance. And so we can virtually vacuum seal food without a vacuum, if that makes sense. So we can vacuum, so this just fell over. So we can vacuum seal food without using a vacuum like a Harvest Right freeze dryer. And what we'll get is basically this thing here. There are several ways that you can seal a jar filled with freeze-dried food. The best way would be using an oxygen absorber and then vacuum sealing it inside the Harvest Right chamber. This is probably the most effective way, but it can be a little bit time consuming. So we're going to review all the different ways of sealing food in a traditional glass canning jar. And what we're going to use for this demonstration is we're going to use packing peanuts as simulated food, which will become evident when later on. So we're going to go ahead and fill this jar up as if there is food in it. This could have an oxygen absorber if you so choose. That would be optional. And you want to seal the lid just as if you're going to use this in a pressure cooker. You don't want the lid too tight, but just snug so air can escape. So the standard procedure to use your Harvest Right vacuum chamber is remove the tray. Now I have a board in here, so I have a flat surface to put my jars on. Go ahead and shut the door. Make sure the valve in the back is closed. Come up to your screen and hit the leaf icon. And here you can choose vacuum. Run your vacuum, for about 2 or 3 minutes. So at the end of 3 minutes, I'm at 1600 millitorr. So we're going to go ahead and turn off the vacuum and reach back here and release the valve and remove our jar. So we're going to go ahead and mark this VC for vacuum chamber, and we're going to put that aside. So what do you do if you want to vacuum seal your jars and you don't have a Harvest Right vacuum chamber? Well, there's another way you can do this. So we're going to take another jar with our simulated food. We're going to go ahead and put a lid on it. And we're going to use this little guy. Now you've probably seen me use this before. This little vacuum pump also can come with the adapters for a regular mason jar and the wide mouth mason jar. Well, in this case, we're going to use the regular mason jar. So we're just going to go ahead and put this little thing on top. And after several minutes, we're going to go ahead and release that. Take off the adapter, and you can feel that it's sealed. I'm just going to go ahead and put the ring on for now. And we're just going to mark this pump. And we're going to put this one aside. But what do you do if you don't have a freeze dryer and you don't have the pump, or you just don't want to bother breaking them out? There is another way that you can vacuum seal food in a glass canning jar without the use of a vacuum, and that is using heat. I place 3 jars in my oven under the keep warm temperature, which is for my oven 170 degrees. Now these jars are hot, so we're going to have to use some precaution so we don't burn ourselves. With these hot jars, we're going to fill them with our simulated food and put a canning lid on them like you'd normally do. Now there's 2 ways you can do this. You can just do the jars by themselves, or you can heat the jar and the food up in the oven together. If you heat the food and the jars up at the same time, you'll get a better vacuum because you have a greater heat source. But both will work, but one will work better. Whether you choose to pre-fill your jars with the food or just to heat the jars separately, I would definitely suggest you use an oxygen absorber in your jars to remove any oxygen that the vacuum does not remove. Now, just for demonstration purpose, I'd removed the simulated food out of this one because I want to can it without any food, but just with an oxygen absorber, so we can see the difference in the vacuums that this will create. So in this one, we're going to put an oxygen absorber by itself. We're going to put an oxygen absorber in that one. This one we're not going to do anything with, just for comparison. And we're going to go ahead and put the lids on here. And yes, this is still very, very warm. Now, as these cool down, they will create a vacuum. And we're going to give this a day or so, and then we'll go ahead and do the water test and see how much of a vacuum these will create. So I'm going to go ahead and mark this OV for oven, OV, OV. So these are our 5 examples of vacuum formed canning jars. We have this one that's from the Harvest Right chamber, this one with the hand pump, and these 3 were heated in the oven to produce a vacuum when they cool. It's been about a week since we sealed these jars up. 3 of these jars were the air inside were heated by an oven. We heated the jars up nice and hot to make the air hot, so when the jars cooled down, it created a stronger vacuum. So we're going to go ahead and test these. Plus I have this jar and this jar. This jar was sealed with a handheld pump, and this jar was sealed in the freeze dryer. So this jar right here was heated in the oven, and it has a single oxygen absorber. So the oxygen absorber would have created somewhat of a vacuum, but also the jar was heated, so we're going to see what the total vacuum displacement is. So we're going to go ahead and open this up. And I'm going to put it down here in the liquid, and we're going to break the seal on the very bottom. So that's the oxygen absorber and the heated air, and that's empty now. I have like simulated food to take up the displacement inside the jar. So this was heated in the oven with an oxygen absorber. So we're going to see how much this will suck up. This is one of the reasons why I went with packing peanuts, because I didn't want to use real food and get the food all mushy. So there's that one there. And we'll actually measure all the liquid on these and see. Now this jar right here does not have an oxygen absorber. So this is just going to be the air that was heated in the oven by itself. So this is going to kind of tell us how much of a vacuum the hot air created inside the glass jar. So not as much, but it did create somewhat of a vacuum. Okay, now this one was a handheld pump. My guess this is going to be about half the jar. Not as much as I hoped. Now this one right here was done in the freeze dryer. This should have the most. Ready to run out of water. If we put these in order, this jar with the simulated food was just heated and then sealed. This jar was heated and sealed with an oxygen absorber. This was heated and sealed with an oxygen absorber and simulated food to take up the displacement of the air. This one right here was sealed with a handheld pump, and this one right here was sealed in the vacuum chamber. So we're going to go ahead and measure the amount of water and see which one did the best. Of course, we know this one did the best. And this one was, the problem with the handheld pumps is it's hard to know how much vacuum you're applying when you're holding that handheld pump. I think I put this on for 30 seconds. So do you run it for 30 seconds? Do you run it for a minute, 2 minutes? So it's kind of hard to measure with a handheld pump. Now going over here, this is probably the most, but anyway, we'll go ahead and measure these 3 right here, because these 3 are the ones we're really interested in, because these were done in the oven prior to sealing. So how did we do on our results of heating the glass jars prior to putting the food in them? Well, we got to make one assumption. We're going to assume that each oxygen absorber removed 21% of the oxygen out of each jar. Okay, so with that in mind, we can look at the results. So with the jar that just had an oxygen absorber by itself, we were able to remove 220 milliliters, or you could say 220 grams of water, which, because we heated the jar, that came up to 24%. So if the oxygen absorber took out 21%, heating the jar took out an additional 3% of atmosphere. So that's pretty good considering it was an empty jar. Okay, on this test had the simulated food inside with an oxygen absorber and the jar was heated. Well, in this case, we were able to remove 261 grams or cc's of atmosphere out of this jar. So not only did the oxygen absorber remove 21% of oxygen, heating the jar removed an additional 17% of atmosphere. So that's really good. But that's with an oxygen absorber and a heated jar. Now just with the heated jar by itself, well, this removed only 105 cc's of atmosphere, and that comes up to 16%. I mean, I was hoping to be a little bit more, but it's really not that bad. So just a heated jar by itself with simulated food inside removes 16% of atmosphere. Now there's still going to be oxygen in that atmosphere, but the best result was having a heated jar and the oxygen absorber. So this is just for this one right here, and this one right here was just for comparison purposes. The best result we received is this one right here. By using a heated jar and heating up the air inside the jar, adding your food, adding an oxygen absorber, not only would it remove 21% of the oxygen, but an additional 17% of atmosphere, which would mean that your oxygen absorber would work better and wouldn't have to work as long. Now, if this was a real world situation, there would be a good chance this oxygen absorber would not be spent and could be reused again if in the future, if this jar was opened and you removed food out of it, you could probably seal the jar with the original oxygen absorber inside, and the original oxygen absorber would continue working. So anyway, those are the results of heating a jar prior to packing in an oven. So this shows that it would be beneficial. It's going to be one more step, so it's something that you'll have to decide if you want to do or not. But it's one way of creating an additional vacuum in canning jars without having a hand vacuum machine. Or what this process demonstrates, that if you heat your jars in an oven prior to canning, with or without food, if you put food in there, you'll be miles ahead. Heat your jars in an oven and heat the warm air inside, and you seal the jar, and when that warm air cools down, it will create a vacuum. So between the vacuum created by the heat, the vacuum created by the oxygen absorber, it works really well. But like I said, it's an extra step. So now we're going to take a look at what we can do with bags. You can vacuum pack using heat with food storage bags, but it doesn't work as well as with glass jars, because glass jars can retain more heat than the bags can. Now I have two bags here. This bag right here is a Mylar bag, so they say. More on that later. But this bag right here is polyester. Whether it's Mylar or polyester, they both work just fine. So the problem we have with bags is they don't have the mass like a jar does. But we can still use heat in vacuum packing, but it takes a little bit of preparation. Another way you can vacuum pack without a vacuum and just by doing heat is with a simple hair dryer. Okay, so I have my 2 bags and they're already labeled, already dated. I got my oxygen absorbers here. My food is in the freeze dryer ready to come out. So I'm going to take my 2 oxygen absorbers and they're going to go inside the bags. So I'm going to go grab the food and we're going to put it in the bags. Okay, I got my mild cheese is going to go into the polyester bag. And my yellow squash is going into the so-called Mylar bag. Okay, so now this food is pretty warm as it is, but what we can do is before we seal these, we're just going to take this and turn on this hair dryer. Now, we're not going to do this. We're not going to put the hair dryer inside, because if you do that, you're going to end up with a fountain of cheese blowing out the top end. We're only going to heat up the side of the bag. The whole point behind this is to heat the air inside this bag until it's warm. Okay, so the bag's nice and warm. We're going to go ahead and fold it over, get as much air out of this as we can. And on this one, I'm just going to do the zip seal here. This one is going to be folded over. And I'm ready to seal these bags. Okay, so I have my 2 bags, one of cheese, one of yellow squash. We'll let these cool down and see what happens. It's been 3 days since I packed up the cheese and yellow squash. Now, these 2 bags were just packed up normally right out of the freeze dryer. The air inside was not heated, and you can kind of see this kind of has a bit of a pillow shape to it. The yellow squash fared a little bit better. It sucked in the sides, but it wasn't too bad. The cheese did poorly though. Now, for comparison's sake, this is the cheese that we did where we heated up the outside with a hair dryer before sealing it, and you can definitely tell that this is nice and tight. I mean, you can see all the little line textures from the shredded cheese inside, and the area around the cheese is nice and tight. So we are able, with the oxygen absorber, to get a really nice vacuum inside of this, almost as if you vacuum sealed it inside a freeze dryer. But this was just using a little bit of heat with a hair dryer on the outside of the bag that warmed the air on the inside of the bag, and then we sealed it up. Now, if you want to take a look at the squash, so this is a squash where we used the dryer on it, and this is a regular squash. Now, it's kind of hard to see, but the squash that we use the hair dryer on is a little bit tighter than the regular squash. But more important is the area around the food is nice and flat, where there are some voids and air pockets with the regular squash. So the hair dryer was able to reduce the atmosphere in the squash prior to sealing, and once everything cooled down, it sucked everything up. So if you take a look at these 2, these are the 2 hair dryer packages, and they did really well. So I'm not suggesting you to do this with everything, but it's a thought that you might want to try. The takeaway from this experiment is this: the warmer the food and the air is inside your bags, when you seal it, that air is going to cool down and create a vacuum, and it's going to remove more atmosphere out of the bags and allow your oxygen absorbers to work better. So I hope you try this out. It does work. It takes a little bit more time, but try it out. Send me some feedback and tell me what you think about it. But I'd like to thank you for your time. Thank you for subscribing. Thank you for your support, and I'll send in another video to you as soon as possible.